Here we have a question to test your understanding of balance. How should the 500-pound weight be shifted to balance the plank on the fulcrum? Well, this could be a balance problem or a trebuchet problem. And we have a seesaw with weights balanced on a plank on either side of this balance point or fulcrum. The question is asking us how far we would need to shift this 500-pound weight. Our possible choices are to shift left or right, so we know the system is out of balance and we need to move the 500-pound weight to make it so. A balance problem requires that we calculate the moments of our system here. In this case, it's not an aircraft, but it's a seesaw. So we'll calculate the total moments on the right and the moments on the left and bring this into balance. We'll need to move the 500-pound weight some distance. The equation for moment is simply the weight times the arm or the distance. So we'll total the weights and distances on the right and find out what distance it needs to be on the left to match. So on the right we have 250 pounds times 20 inches, which equals 5,000. And we have 200 pounds times 15, which equals 3,000. So we have a total moment of 8,000 on the right, which has to be matched on the left. So take 8,000, divide by 500, and that's 16 inches. So we need to move that block 1 inch to the left to bring this into balance. Perhaps a more systematic way to solve this would be basic algebra. We can make an equation to balance the weights and distances on the left with the weights and distances on the right. We know 15 inches is not correct, so we'll just call that x and write out a formula. So on the left, we'll have 500 times x must equal 20 times 250 plus 15 times 200. And then we'll solve the equation for x. First we'll simplify the equation, and then we'll solve it for x by dividing both sides by 500. Again, we see that the arm on the left needs to be 16 inches. And our answer is 1 inch to the left.